Hey everybody. So the last class we worked on finding the vertex of a parabola of a quadratic function, and we also worked on finding intercepts, the kind of points that help us know how the graph will be shaped. This time we're going to do section 8.5 plus a little extra, and we're going to work on mainly just graphing these things. But we have enough background that this will be actually pretty simple. Now I do want to say we're really nice here. I look back at all the old tests we've given over the last few years, and there are two ways we could give this to you. One way is as a quadratic function, and that's what we've been looking at. So like f of x equals, it doesn't really matter, 2x squared plus 3x plus 5. Or we could give it to you in vertex form. So vertex form is just when people have done some magical algebra, not really magical, done completing the square, which we're not going to test you on, and they write it in this way. This way is special in that you can just look at it and pick off the vertex. Now I'll explain. This way is not. This way, the only way to graph it is to, well, we're going to make a table for both. But when you graph this, you don't know where the vertex is. So you would have to find the vertex, then make a table. So that's actually going to be the same process over here. We're going to find the vertex and make a table, but there's no work to find the vertex. Vertex form is really nice. Let me give you the generic form of vertex form. The generic way of writing it is x minus h squared plus k. So let me tell you how we pick off the vertex. Okay? The vertex will be right in here. Okay, they use an h and a k. So it's minus h. So if this is ever a plus, then our h number is the opposite then, okay? So minus 3. So the vertex here is actually hk. So the vertex for this thing is really easy to find because all I have to do is look, it's minus 3, so that's the x value, the one that's inside the parentheses with the square. The x value is 3, and plus 1, that's outside the square, that's the y value. And here's how I remember this. Whatever is inside with the x is the x value, and it's going to be opposite of what you think it should be. This is minus 3. You might want to feel like it's a negative 3, but it's actually positive 3. And the one outside is the y value, and it actually is whatever its sign says it is. Positive 1, so it is positive 1. Now, to graph these, we get the vertex, and we still make a table. I'm going to want 5 total points in your table of values. But you have 1 already with the vertex, so 2 on each side. Of the vertex. Okay? And then when I say a table, I mean an XY table of values so that we can easily graph these parabolas. And remember, the shapes are going to be parabolas, these big U-like shapes. So let's actually graph a few, try some examples here, okay? So let me give you the first example. Let's go with f of x is equal to x minus 2 squared minus 4. So first thing is, can you find me the vertex? And this should be, hopefully, really simple. You'll get really fast at this. So there's the x value of our vertex. It says minus 2. Remember, the formula had a minus in it, so we want a minus there. That means this x value will be positive 2, or basically you can think of the opposite of what's written right there. And the y value will be what is added or subtracted outside, so minus 4. So there is our vertex. So to graph this, we are going to want an XY table. And we're going to want to just go on each side of this vertex. So let's see what would be next. 1 and 0. What would be after it? 3 and 4. How am I going to find the x values now? Just plug in these. Sorry, how am I going to find the y values? Just plug in these x values. So scratch work, we'd want to do f of 0. 0 minus 2 squared minus 4. We can probably do this in our heads. Negative 2 squared is 4. 4 minus 4 is 0. Okay. So now let's plug in 1. We might be able to do it in our heads. We might not. It's okay. If I plug in a 1, 1 minus 2 is negative 1. What's 1 squared? Well, 1 minus 2 squared minus 4. Negative 1 squared is 1. What's 1 minus 4? Negative 3. Okay, awesome. Can I plug a 3 in? And the answer is yes. What you're going to find is, what's beautiful about graphing these is these have symmetry. They're going to be identical as long as I keep the steps identical on each side. You don't believe me? Try it out. F of 3. What's that going to be? 3 minus 2 squared minus 4. Oh, what's 3 minus 2? 1. What's 1 squared? 1. What's 1 minus 4? Negative 3. Hey, that looks familiar. That's what was above it. If I plug in the 4, that'll be familiar as well. 4 minus 2 squared minus 4. Wait, what's 4 minus 2? That's 2. It's 2 squared. 4. 4 minus 4 is 0. Wait, that looks very familiar. So getting these 5 points with vertex form, which is what we will ask you on the test, is actually a pretty simple chore. Now let me see if I can do this graph by hand without getting too messy. Oops, I get a little bit sloppy there. So let's graph our points. I got 0, 0. 1, negative 3. So over 1, down 1, 2, 3. 2, negative 4 is the vertex. 2, 3, negative 3. And 4, 0. 1, 2, 3, 4. Now, does this look like a parabola? And the answer is yay. Yes, it does. My graph's not too hideous. So that's all we really are working on today, is can you graph these things? And you will be tested on this on the test. So let's try another example. Let's do one like this. How about f of x equals x plus 2 squared plus 5. And so can you find the vertex? Now this one's a little bit trickier than the last one. The y value is the easiest, plus 5, positive 5. Remember, it's supposed to be minus something. Because it's plus, it's always the opposite sign of what's here. So what's the x value here actually? Negative 2. So if I go to make my table here, my xy table, remember I want 5 points, and I want the vertex in the middle, 2 on each side of this x value. So negative 2, negative 3, negative 4. Those are 2 numbers below it, and 2 numbers higher than it would be negative 1 and 0. So those are going to be what I plug in to get the y values and graph it. The only difference here is we had a plus, so that makes finding the vertex a little bit sketchier. But let's see. Let's plug in negative 4. Negative 4 plus 2 squared plus 5. Let's see. Negative 4 plus 2 is negative 2. But negative 2 squared is just 4, right? 4 plus 5 is 9. Okay. Let's plug in negative 3. Negative 3 plus 2 squared plus 5. Negative 3 plus 2, that is negative 1. What's negative 1 squared? Positive 1. And 1 plus 5 will be 6. And then I have a feeling these answers are going to be 6 and 9 because of that symmetry I'm talking about. But let's try it out anyways. Negative 1. Let's see. Plug in negative 1 plus 2 squared plus 5. Negative 1 plus 2 is 1. 1 squared is 1. 1 plus 5 is 6. And if you put a 0 in there, you probably can do this in your head. 0 plus 2 is 2. 2 squared is 4. 4 plus 5 is 9. so then I can graph it. Gotta go up high enough on my graph to fit this one. Let's see, I got -4, 9. 1, 2, 3, 4. Whew. How many did I count up? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 9. -1, 2, 3, 6. My graph is not perfect, but there we go. -2, 5. -1, 6. And 0, 9. So there's my beautiful parabola. Awesome. Now, last time we asked you to be able to find a few things. We wanted you to be able to find the vertex and the intercepts. So I ask you those same questions. Can you find me the vertex and the intercepts of these same examples? And the answer should be yes. So don't forget that from last time. Remember, you can also pick these numbers off of looking at the graphs. Does this one cross the y-axis? No. So it'll be like that one example we did where we had no real. We had complex or imaginary ones. Does it cross the y-axis? Is there a y-intercept? Yeah, it's right there at 0, 9, right? Okay. So I want to do one more example of graphing these, and I want to see what you think if I take this and write it this way. X equals y minus 1 squared plus 2. This is kind of weird. This is not a function. We're not writing it as a function. And notice I don't have an x here. Notice I switched the inputs and outputs. So what this is going to do is it's going to turn the graph sideways. It'll be a sideways parabola like that. Can I still treat it mostly the same way? And the answer is yeah. Can I find the vertex? Yeah, I can. What will the vertex be? Now we have to be kind of careful with this. This will be a little bit tricky. What will the vertex be? I have a feeling. Let's see. We want to say it'll be 1, 2. Is that going to be right since I switched the x and y values? I don't know. You tell me. How could we figure this out? How could we experiment? The experiment could be that we go ahead and do an XY table and put this in the middle. Now, I can't pick x values and plug them in. I'm going to need to pick y values. And we could go on each side of this. Would this work? Let's see. 1 and 0 and 3 and 4. And you try to see if we have this symmetry. If you put a 1 in, 1 minus 1 is 0. 0 squared 0 plus 2. So that would be 2. And let's see if this would give us that symmetry of giving us a 2. Let's check. If I plug a 3 in, 3 minus 1 is 2. 2 squared is... No, this gives us... So I have a feeling, just with a little bit of experimenting, that this isn't the vertex. But I switched the x and y. So maybe... Well, just maybe the vertex is in the wrong order. Because I switched the x and the y, let's try that. Let's switch these. Let's try that again. Let me get a whole new paper and try that again. I'll go ahead and tell you that's what's up here. So let's see. What's my example? X equals y minus 1 squared plus 2. So maybe, just maybe, the vertex, since I switched the x and y, so be very careful about this, because I have the y here, this vertex will have a y value of 1 and an x value of 2. Now, I'll go ahead and tell you that's probably what we're looking for, right? Let's go ahead and make our table, our xy table, and let's put 2, 1 in the middle, and let's pick. Now, once again, what am I plugging in this time, or y? So let's pick 2 numbers on each side of y, and let's see if we get that symmetry. Then we know we did things correctly. So if I plug a 0 in there, x equals 0 minus 1 squared plus 2. We can probably do this pretty easily, right? 0 minus 1 is -1. Squared is 1. 1 plus 2 is 3. Okay, let's do -1. X equals -1 minus 1 squared plus 2. -1 minus 1 is going to be -2. -2 squared is +4. 4 plus 2 is 6. All right, let's see if we get the symmetry. Let's see if we get 3 and 6. Let's check that. So if I plug in 2 minus 1 squared plus 2, let's see. 2 minus 1 is 1. 1 squared is 1. 1 plus 2 is 3. That's good. Now let's check this one. X equals 6 minus, not 6. What are we plugging in? 3. I'm so crazy. 3 minus 1 squared plus 2. That is 2 squared is 4. 4 plus 2 is 6. Awesome. So just remember, when we switch the x and the y and we find the vertex form is backwards. Okay? So can I graph this? Yeah, let's see what this will look like. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. Let's see. Here I got 6, -1. 1, 2, 3, 4, 5, 6, -1. I have 3, 0. I have 2, 1. I have 3, 2. And I have 6, 1, 2, 3. So does this look like a sideways parabola? And the answer is yeah, thank goodness. So I tried to make a big deal with that. Sorry if I confused you. I just wanted you to discover that I can switch the x's and the y's, and that gives me a sideways parabola. But it works exactly the same. So now I have one last idea. We'd like to be able to graph circles. Okay? I'd like to be able to graph circles, and I'm going to tell you that this is actually very, very similar to what we just did. Okay? Circles are going to be given to you in this format. Okay? And so what we're going to be looking to pick out is the center of the circle and the radius. Whoops, I forgot the square. I haven't finished writing it. Radius. And those are going to actually be right in front of us. The center will be the h and the k. The x and the y values of the center will be the number with the x and the number with the y. Notice it's opposite signed. Minus h gives us a positive h. Minus k gives us a positive k. And the radius is sitting right there. That's just r. So we can easily pick those things up and be able to graph it very, very quickly and easily. So let's actually do a real example. So let's see. Let's do x minus 3 squared plus y minus 5 squared equals 16. So the center should be really easy to pick off. What's the center here? Well, what's the opposite of -3? +3. What's the opposite of -5? 5. The radius is a little bit sketchier because some people want to say it's 16, but this is the radius squared. What's the square root of 16? Or what is that squared? That is 4, so the radius is 4. So can I graph this? And the answer is yes. Not hard to graph. I don't even need to make a table. I need to go to this point. 1, 2, 3. So the point, let's get some more graph here. The point is 3, 5. So 1, 2, 3. 1, 2, 3, 4, 5. Right about there. What's the radius? 4. So I just want to go 4 up, 4 down, 4 left, and 4 right, and put those points, and that'll be enough to graph this circle. So 4 down, 4 up, 1, 2, 3, 4. 4 to the left. No, it's not a perfect graph, but and 4, 1, 2, 3, 4. 4 to the right, and try to draw your circle the best you can. My circle's a little lopsided, but okay, there we go. Sorry, it's ugly. It looks more like a lemon, but that's how we're gonna draw the graphs of circles. Now, I will tell you, some classes are very mean and they won't give it to you in this special form. You have to do this completing the square thing with the x's and completing the square with the y's. But since the university has decided not to test you on completing the square, we're going to give this to you in this nice, beautiful form. Let's do one more example. How about x plus 2 squared plus y minus 1 squared equals 9. So can you give me the center? Where's the middle of this circle? The answer hopefully is yeah. The x value will be, what's the opposite of positive 2? Negative 2. And the y value is, what's the opposite of minus 1? Positive 1. And then the radius. Can you give me the radius? Important question. Is it 9? No, it's not 9. 9 is what squared? 3 squared. So I should be able to graph this now. 1, 2, 3, 4. 2, 3, 4. Alright, so where's my center? Negative 2, 1. 1, 2, 1. What's my radius? 3. So I'm going to go 3 up, 3 down, 3 left, and 3 right. 2, 3. 1, 2, 3. 1, 2, 3. And if we're trying to go to scale, this is 1, 2, 3. Very not to scale. On a piece of graph paper, this would make a perfect circle, but it's kind of horrible looking. But anyways, that's all we want you to get from this, is how to graph a circle and how to graph parabolas. So try the worksheet. I'll post the answer key. Check your answers. Email me any questions you have so I can answer those questions. You'll have an awesome day.